welcome to Unit 3 of the module on Pedagogical Content Knowledge in Physics. And in Unit 3, we'll be looking at developing PCK for the teaching and learning of physics. And in the first session of this unit, we will be looking at scientific units of measurement. My name is Patrick AJ. Now, at the end of this session, you should be able to explain units as used in physics, differentiate between base units and derived units, state the different types of units used in physics, and finally, state the importance of units in measurement. Now, let's look at scientific units. And to look at scientific units, we must define what measurement is. And measurement is a process by which humans quantify their interactions with the environment. So how we quantify our interaction with the environment is what is being termed as measurement. So in our daily life, we can fetch a spoonful of sugar, a cup of water. You walked for 10 miles. You slept for 8 hours. All these are ways in which humans quantify their interactions with the environment. And the measurement results in a physical quantity that consists of a pure number and a unit. So, for instance, when you say you slept for 8 hours, the pure number here is the 8, and the unit becomes the hour. So a physical quantity is a quantity that can be measured either by an instrument or by calculation using an appropriate equation. So every quantity that we can measure either using an instrument or using a calculation is called a physical quantity. And we made mention that every physical quantity consists of a pure number and a unit. And so units are words or group of words that are written against the numbers to indicate what those numbers stand for. So when we have a number, so for instance, you enter your class one morning and in your hand you have 10 CD notes and you have a cane also in your hand. Then you write 10 on the board. Then you ask your students, come for 10. Now you realize that the students will start contemplating, is it 10 CDs the teacher is calling me to come for or 10 lashes? But when you should write, come for 10 Ghana cedis, you see that all your students are going to run towards you because they understand the unit, that is the CD, which has been added to the 10 to make it something that is being understandable. Now, there are many unit systems that are used today, and we have 4 main sets of units that are being used. And these 4 main sets of units are the SI unit, or what we call the meter, kilogram, and second unit. And we have the CJS unit, that is the centimeter, grams, second unit. We also have the, imperial unit and natural unit. So, let's look at the SI unit, or the meter, kilogram, second unit. And this is also referred to as the System International. And these are the internationally agreed upon units. It means they are the units that are used, that are accepted everywhere. And these units are based on the metric system, which was developed in France at the time of the French Revolution. And all physical quantities have units which can be built from the 7 base units. And so let us look at the base units. And when we say base, or the fundamental units, they are units from which other units are obtained, and we have 7 of them. And the 7 units are length, measured in meter with the symbol small m, mass measured in kilogram with the symbol small k, small g, time measured in second with the symbol small s, electric current measured in ampere with the symbol capital A, thermodynamic temperature or temperature for short measured in Kelvin with the symbol capital K, amount of substance which is the mole and the symbol is MOL, and the luminous intensity, name of unit candela and the symbol CD. Now, why are these units called basic units or base units? They are called base units because none of them can be expressed as a combination of the other. And we should also know that units are always written with lowercase initials. So when you want to write the meter, then we write M, small M-E-T-R-E. And the symbol is also small m. However, when there are some units that are named after scientists, so like the unit of electric current named after ampere, although we start with writing such a unit with small letter, that is AM, but the symbol is capitalized. So let's take note of that. Now derived. And derived units, they are units obtained from the combination of two or more base units. And these are some examples. These are not the only derived units. So we have force, which is mass times acceleration, and units expressed in base units is the kilogram meter per second square, and the name of the combination will give us the Newton. We have work and energy. We also have power, which is work done divided by the time taken, and the name of the combination is the watt. Now let's look at prefixes. And prefixes are decimal multiples and submultiples, which represent very large or very small figures. So you realize in basic school, normally we will tell them that the mass of an electron is negligible. Why negligible? Because when you look at the mass of an electron, that is 9.1 times 10 to the power negative 31 kilograms. Now this figure tells us that when we want to write the mass of an electron, then we have to write 0 point, and the student will have to write about 30 zeros before he or she will add or get to the first significant figure, which is 9. And so we say that this figure is negligible. However, as we move on, that is when you get to higher levels of physics, from the senior high level, you realize that this mass of an electron is not negligible. And we should be able to write it in ways that are too simple, yet giving the same meaning. And so these prefixes, they are decimal multiples, and they represent very large or very small figures. So these are some examples of the prefixes. So we have iota, that is the number 10 to the power 24, through to deca, which is 10 to the power positive 1. And when we come to the negative, we have deci, which is 10 to the power negative 1, and yocto, 10 to the power negative 24. So you see from here that the giga we have been saying, I have a memory card of 10 gigabytes. That 10 gigabytes means you have a memory card of 10 times 10 to the power 9 bytes of that size. And if we are to be writing all these values, you realize there's going to be a very huge value written on that small flash disk. And so we use the symbol G to represent the gigabyte. And the actual value is 10 to the power 9. Now let's look at the other unit. That is the centimeter gram second. That's the CGS unit. And in this system, the meter is replaced by the centimeter and the kilogram is replaced by the gram. You observe that the time is still second. And this is a simple change, but it means that all units derived from these two are also going to be changed. And so, for example, the unit of force and work will then be different because they have mass in them. And these units are used most often in astrophysics and also in atomic physics. So in areas, sometimes when we want to measure the mass of, let's say, a charge, mass of an electron, or when we want to measure mass of minute particles or the subatomic particles, we normally measure them either in the gram, That's in the smallest unit of the mass. The imperial unit. These units stem from the days when monarchs decided measure. And here, all the base units are different except the measure of time. And these units are used by the Americans and the British. So in our system, we do not use it. And examples of such units are measuring length in inches, feet, yards, miles, measuring area in square feet, measuring weight in pounds, ounces. But you realize that if we are using these units, then what it means is that scientific communication is going to be very difficult because different units will be used at different places. And for that reason, we adopt the set of internationally agreed upon units, which is the SI unit. Now let's look at the natural unit. And this is the most sophisticated choice of units. Here, the most fundamental discovered quantities, such as the speed of light, are said to be equal to 1. And for that reason, all other fundamental units are to be built around this basic idea that the speed of light is said to be equal to 1. And this system of units is used in high energy physics and quantum mechanics. An example of such units is the elementary charge, which has the unit E, and this is the unit of electric charge. The speed of light c is also the natural unit of the speed of light. What are the importance of units? And units give meaning to the numbers we calculate. So after your calculation, when you just write a number, it is seen as a number. But the moment you finish writing your number and you write a kg attached to it, everybody sees it and knows that this figure or value you have presented is referring to the mass of a certain quantity. Units are also an essential part of the language that we use. Now, students, in this session, we look at scientific units as well as the different types of units used by scientists. And these units are the SI units, or the meter kilogram second unit, the CGS unit, that is the centimeter gram second. We also have the imperial units as well as the natural units. Thank you, students, for your time, and thank you for joining this session. See you in the next session. Bye.